We get the compound alkyl halide when we replace one of the hydrogen atoms from an alkane molecule by a halogen molecule such as chlorine, fluorine, bromine or iodine. It is generally represented as Rx. Okay. Now the IUPAC rules suggest that it should be named as haloalkane, where halo is the prefix for halogen and alkane is the chain length of the alkyl group. Okay. So for fluorine we use fluoro, for chlorine chloro, bromine bromo, and for iodine we use the keyword iodo. Let us see some of the examples to understand and apply this rule in a better way. Let us begin with our first example. We have a simple hexane molecule with us, and if we replace one hydrogen atom with a halogen atom, let us say chlorine, then we will have an alkyl halide. As per the IUPAC rules, we will name it as haloalkane. So this will be named as chlorohexane. In addition to this, we will also represent the position of chlorine in this parent chain with 1, since it is attached to the first carbon atom of the hexane molecule. Okay. Now let us move on to our next example, in which we have shifted the position of chlorine to some other carbon atom in the parent chain. Now if we have to write the position of this chlorine atom, we can do this either starting from left to right or from right to left. Okay, we will choose that direction which will give this chlorine atom the lower position. If we position it from left to right, then it will have the fourth position. On the other hand, if we do it from right to left, then it will have the third position. So we will choose the lower value of these two positions. It will be named as 3-chlorohexane. Okay. Now in our next example, let us introduce another substituent along with the halogen atom. One point we would like to note here is that halogen atoms are also treated as substituent in every case. So we will not differentiate between methyl and chlorine atom as the seniority of functional groups. Okay, we will treat them both as a substituent, and we will start positioning from that direction which will give both of these substituent the lower position. So if we start from left to right, then methyl group will have second position and chlorine will have fourth position. On the other hand, moving from right to left will give chlorine the third position and methyl the fifth position. So we will follow the numbering system which gives lower position to this substituent. So the compound will be named as 4-chloro-2-methyl-hexane. Please note that while writing the final name, we arrange the names of the substituent in the alphabetical order. Before moving further, let us get familiar with an important rule regarding the parent chain. In this example, we have three possible chains starting from A to B, A to C, and from B to C. In our earlier discussions, we have learned that we must select that chain as the parent chain which has maximum number of carbon atoms present in it. Here, if we go from A to B, we will count that there are 7 carbon atoms. From A, starting from here, first carbon atom to 7th carbon atom right here. If we go from A to C, we can see that there are 6 carbon atoms. Okay? And now if we go from B to C, there will be 4 carbon atoms. We can discard it right here. Now we have to choose the parent chain. We have a chain of 7 carbon atoms and we have a chain of 6 carbon atoms. Well, as per our earlier discussion, there should be no dilemma right here. But in case of functional group, we must include functional group in the parent chain. Okay, so this is a new rule introduced here when we have some other functional groups in an alkane molecule. Okay, so if we choose AB as the parent chain which has 7 carbon atoms in it, then this entire group will be the substituent. Okay, well, in this case we cannot choose AB as the parent chain. Rather, we will choose AC as the parent chain, in which case this group right here will be the substituent. Okay, so we will consider this particular compound as an alcohol. Okay, and we will name it as per the rules decided for an alcohol, which we will learn in subsequent slides. Now let us get started with an alcohol group. We can understand its structure in the same manner as we did for alkyl halide. In this case, we replace the hydrogen atom of an alkane with an OH group and this compound becomes an alcohol. As per the IUPAC rule, we write its name by adding the suffix "ol" to the respective alkane to which it is attached. Okay, so for an alcohol, the suffix that is used to identify it is "ol." We will go on and note down the suffix of each functional group as we study. Let us now see some of the examples and apply this IUPAC nomenclature rule for naming an alcohol. Let us use the same reference of hexane molecule as we did earlier for the case of alkyl halide. We have replaced the hydrogen atom with an alcohol group here. It has 6 carbon atoms in the alkene molecule, so we will name it as hexane and we will add the suffix "ol" to it to signify that this is an alcohol molecule. So the name of this group will be hexanol. Hexane for the parent chain and "ol" for the alcoholic group. Okay. Our next example is similar to the one that we did in case of alkyl halide. We have shifted the position of alcohol group and without any further discussion, I am sure that you have already come to know the name of this compound. The name of this compound will be 3-hexanol. Well, we will represent the position of alcohol here with its position, which represents it in terms of lower value. So 3 will be the appropriate choice. Now let us move to our next example. We have introduced an alkyl group along with alcohol. In case of alkyl halide, we did not differentiate between methyl and halogen group, and we numbered it from that direction which give either of those two substituent the lower position. But now in presence of alcohol group, we will number this molecule from that direction which will give the alcohol group lower position. So starting from left to right, the alcohol will have fourth position. On the other hand, starting from right to left, the alcohol group will have third position. So we will choose the lower value for the alcoholic group. Okay, so here is the difference, that in case of functional groups shall be given the lower position when it comes to numbering, irrespective of the position of the methyl group. Okay, so this compound will be named as 5-methyl 3-hexanol, where 5 represents the position of methyl group. Counting from right to left, it will be numbered as fifth. 3 represents the position of alcohol and hexanol, as we did earlier. Having learned the rules for writing the IUPAC names of an alcohol group, now I am leaving you with these two examples. Please try to write the IUPAC names of these two compounds as per your understanding and post the same on the comment section of this video. I will upload the correct answer in the comment as well, where you can check it. Let us quickly recap what we have learned so far, both for the alcohol and alkyl halide. First of all, it is a general rule that parent chain must include the functional group, even if it is shorter in the entire molecule. Next, an halogen atom is always treated as a substituent, no matter to which molecule it is attached. It will always be treated as a substituent and its name will appear in the prefix. An alcohol group is identified by adding the suffix "-ol" to the alkane with which it is attached. And finally, we will introduce a new rule for alcohol here. An alcohol group may be treated as a substituent if there are some senior groups present in the molecule. In that case, alcohol will come into the prefix of the molecule and its prefix is hydroxy. We will see examples related to this point in our upcoming video. So thank you so much for watching, and in our upcoming video we will learn about writing IUPAC names of ether and ester. See you in the next video.